Hi everyone, welcome to the session 2 of the faculty development program for uh, national mission on Madan Mohan Malviya mission on the training the teachers. So we finished with OpenStack from Ghanshyam Man, and it is an ideal time to hand over to Professor Gokhale, as we call him. He's the president of Emerging Open Technology Foundation and an independent consultant working in various industries. He started his career as a what do you call professor, and then also worked with various embedded systems in the early days called Sara Electronics, I believe. And then there he did actually board building and all, and trying to port the booting in those days in 80s. Then eventually he graduated to providing students. All his students are all over the world, including Bay Area, in Silicon Valley, in US, in India, and various places. They are all they can vouch for him any day. And we were fortunate to come together again and being able to uh, bring the Emerging Open Technology Foundation. As a co-founder, I think he has got the skills and the ability which can match any industrial guy. He also consults for like L&T and other big companies here in Mumbai, and his projects and his student projects have won laurels, including in China, US, and so we look forward to his introduction for us to cloud and edge. It's a continuum of cloud to the edge, and let's have him on the floor. Floor is yours, Gokhale sir. Go ahead. Take
Thank
it.
you very much, Prakash, for the nice introduction. And those are very sweet words. It once again pulled me back in time since the time we first met in IIT. Thank you very much. And my topic for the day happens to be a brief introduction to Edge, but I'll be taking this introduction to Edge starting from the point of how people know about using cloud infrastructures. So I'll be looking at what exactly is typically required as constituents to make up a sort of an edge-based deployment for a typical use case. So I'm not getting into any system side discussion, but I'll be getting into looking at a couple of use cases and then see how these use cases can be typically brought to life. Okay, so that would be the context. So what I will talk about initially would be based out on these four topics. I'll be giving a brief introduction to Edge, and after that I'll be typically looking at what exactly is required to make computing at edge possible, and we will see all those so-called technologies like 5G coming into picture, Kubernetes or container type of implementations coming into the picture, and how do you typically talk about setting up your network edge, the so-called far edge, the near edge. The classic terminology which goes into edge computing. I'll try to demystify them, and I'll also take up a couple of use cases wherein I'll also introduce what type of hardware and the tools are typically in vogue so as to get onto an implementation. Right. So I'm taking up a couple of use cases, and then I'll be talking in the context and perspectives of these use cases. So let me just get on to a brief introduction, and to set the context, what I will do is I'll not get in the normal way of introducing the topic, but let me just look from an application perspective. So I'll take a few use cases, and from those use cases, I'll try to understand what is required to implement maybe a few of these use cases, what exactly is the common denominator across all these use cases, and then how we can have edge technologies to help us in implement and roll out these sort of use cases. So that will be my talk for the day. So this is the first use case, which is typically a very popular use case from the context of edge implementations. We have video on demand and 4K TV and then streaming type of applications, both from media as well as content which are consumed by these gamers, right? Gamers essentially have got some high-end gaming platforms, and they focus on content which has to be provisioned to them with the least possible latency. Now that is the primary requirement. And it is not just only content. What normally happens is the content that comes to their endpoints has to be instantaneously operated upon. Something like, bare minimum, it has to be rendered in maybe a three-dimensional formats in terms of their interactions, and that has to be presented onto their devices, right? So the requirements are pretty very stringent out over here in terms of delivery of content. And what is the bottom line here? Latency. The latency has to be absolute minimum out over here. And not just only the latency in terms of delivery of the content, but we also talk in terms of what exactly is the type of processing that I need to carry out as the content gets delivered to the endpoint consumption point, right? So typically we could have this processing to be done at a central infrastructure, and whatever is processed, can be delivered to the edge or delivered to the endpoint. Or the new paradigm is where you can just actually set up the processing infrastructure also at the point of consumption. And that is exactly where we are trying to migrate towards. So this is the first use case. The second use case is a very important use case in the context of IoT or industrial IoT requirements. And out over here, the standard IoT model is a scenario wherein you have got a bunch of sensors from where you pick up real-time process data. And this particular process data is slightly cleaned up, and then it is instantaneously published onto the cloud. Now you have got a lot of gateways which do this basic operations. And people write applications on the back end wherein they perform all the analytics that are required, and the data is ultimately visualized by the people who are interested in consuming this particular data, right? So from the consumer point of view, it is either a scenario where if it is in the form of some notifications and event related information, the data is pushed to the consumer. Or if the user is really interested in monitoring some status, the data could be pulled out from the central repositories. So that is how you normally have the entire scenario set up out over here. But the new requirements which are coming up in the context of industrial IoT happen to be a scenario where they would like to reduce this sort of a latency, peaking at less than 50 milliseconds, which currently is not happening. If you look at even the IIoT implementations, you just are okay with having a latency of somewhere around 80 to 100 milliseconds. So the goal is to reduce this down to 50 milliseconds. So how do you typically do that? Once again, let us try to bring in the computational infrastructure as close as possible into the gateway itself. So if my gateway is just not only doing a front-end processing, but if at all it can do a little more than that, maybe it can run a bunch of analytics out there itself, or it can primarily do some sort of a notification type of a application right there itself at the gateway side. You can just have a different type of a model of delivery of information to the stakeholders, right? So this is the second use case which I'm also going to talk about. The third use case is primarily for an enterprise, right? Normally we see the model where an enterprise has their local infrastructure, a private infrastructure. All that entities would be connected over a local area network, or probably also on a wide area network on a local infrastructure, maybe on a private network, or maybe a local network. And they normally would be using a cloud infrastructure, could be a private cloud or a public cloud, and that cloud infrastructure is their normal information repository, I should say, right? They would be having some user-facing applications running from the cloud and so on and so forth. The classic example is, if at all you take an organization which is not into, let's say, an IT organization, it's in some other domain. These people would be having a cloud implementation primarily focused around Office 365 centered applications, or they would have a cloud implementation along project management applications and stuff like that, right? Now the question is, when they have this sort of a implementation, the first and foremost worry for these enterprises is about data going outside of their premises. So is it possible to come up with a scenario wherein they can set up a cloud-like infrastructure which is within the enterprise. Please once again understand, this is not a private cloud per se, but this is a smaller instance of a cloud infrastructure which can be part and integrated with the existing infrastructure, and this is made available for consumption by the enterprise whenever they want it in a more secure manner. So this is another use case wherein this so-called computing facilities can be brought in across into the closest point from where the organizations typically try to connect over to a public cloud infrastructure, right? So there is a third use case. And the fourth use case is a classic use case that people always talk about, is the connected vehicle or autonomous vehicle architectures. If you understand this use case, most of the requirements is a scenario where you have got a lot of local processing to be done within the vehicle, between the vehicles, and you may also have to interact with the infrastructure which is set up across on the roadsides. So you have got a model which is an interfaces which are defined between the vehicles or between the vehicle to the infrastructure that is set up onto the road, or probably also have an application where you touch back onto your backend cloud infrastructure from where you are going to extract a lot of content. Something like, you have a map application, and the map application will have to deliver the map and the navigation information from an application which is running on the core cloud infrastructure, right? So for this sort of a scenario, it is once again a good use case wherein we probably try to bring all this infrastructure as close as possible to the point of consumption, right? So that is exactly what we are going to typically discuss. So here also the requirement is that we need a low latency infrastructure, which is primarily responsible to provide the information with a latency in and around maybe 5 milliseconds, and also give you the infrastructure which is capable of performing decent enough computation. So we will look at this particular use case as well. So across all these 4 use cases, what is the common denominator, right? The first thing that is needed is some form of a cloud-based infrastructure. Now, when I say cloud-based infrastructure, we typically know a cloud infrastructure is normally created using a virtual machine implementation over a shared resource and so on and so forth. So similarly, we need to have a virtualized sort of infrastructure which behaves as if it is a cloud-like deployed applications. Second thing which we need to also ensure about this cloud-based infrastructure is it should be provisioning us or giving you the required infrastructure to handle a variety of workloads. The workloads are need not be necessarily all similar in nature. So it should be created in such a manner that it can handle a variety of workloads. We will talk about what these workloads are in a little more detail in the subsequent slides, right? So this is the first requirement. So you require some form of a cloud-based infrastructure. The second form of requirement is a case where we have to provide the processing capability of high velocity data which is occurring at a very rapid rate. We talk about high velocity data that has to be processed, and we cannot have this data go to the central infrastructure, the core infrastructure, get processed out there at the so-called backend, and then come back here for consumption. But this data has to be processed then and there itself. It has to be processed at the endpoint. So that is the second requirement. And the third requirement is, if at all this user has to get the outcomes and the results of this entire operations, then obviously I have to ensure the fact that this information is made available to him in a timely manner, for which I need to provide a low latency network. So these are the 3 major goals, and then we will see what exactly is needed to set up an infrastructure which meets up all these 3 major goals. So when you talk about a cloud infrastructure, I think everyone knows about what this cloud infrastructure is. Everyone is a party to using this cloud infrastructure, knowingly or unknowingly. And essentially, it is just nothing but a service-oriented mechanism of delivery and use of IT resources provisioned on demand. You use the infrastructure, you use the platform, you use some software applications on demand. And these are all made available by service providers on shared pools of resources. So infrastructure is made available from huge data centers by the so-called big service providers, and applications are essentially multi-tenant implementations that are provisioned by the so-called application providers, right? They could be, once again, big and small application providers. They make these applications which are cloud-enabled applications. So these are primarily delivered for consumption in a shared manner. What are or what exactly is the way these applications are provided? They are made available in what is called as a environment agnostic way, right? They are not dependent upon the underlying environment. They are not even dependent upon the underlying hardware, right? So primarily they are totally isolated from the underlying hardware, right? That is what exactly a cloud infrastructure ultimately is going to provide, right? So with cloud deployment, we normally talk about different forms of cloud deployment, or different models, as we call it. We have got the private cloud, where the entire cloud infrastructure is owned by the organization, totally in a secure place, so privacy levels are the highest. Then we have got a public cloud, where the cloud infrastructure is set up by service providers, and you can just set up your sort of subscription account and then start using the infrastructure by paying a subscription fee. And a private public cloud essentially happens to be a shared resource, so security might be guaranteed, might not be guaranteed. It depends upon the trust the organization tries to place on the security models set up by the provider. Then you have got a community cloud, where the cloud is essentially set up for a given type of a community. And I have a community of users. Let's say I've got a community of SMEs, of a particular type, and a bunch of applications are created which are suiting all this community of users. So you can have a community cloud, so that this cloud is typically used by all this community of users. And as the name goes, the hybrid cloud is a amalgamation or a mixture of all these type of deployments. So the reason I'm talking about this is, once again, you could have an edge infrastructure, which could be a private edge infrastructure, or it could also be a community-oriented project that has been taken up so as to service the requirements of a community of users. And we will see these sort of edge cloud deployment models as well. So this is a landscape which I've provided about all the infrastructure providers. You have got these infrastructure providers like Amazon, Google, VMware, Azure, Oracle. You have got a whole bunch of these infrastructure providers. Each of them have their own way of provisioning, but ultimately from an application point of view, there would be a minimal type of a dependency in terms of the underlying cloud platforms, the hardware platforms, right? So you get everything in a virtualized manner. What are the major challenges, if at all I just go on to these people, right? I just have these providers, and if these particular providers give me some form of an infrastructure, what exactly is the primary challenge for this? The first challenge is latency. The latency normally is reasonably high, might not be suitable for a typical class of applications. The second challenge is about data privacy. I need to also understand the fact that maybe all this cloud infrastructure might be secure or might not be secure. It's up to us to implement additional models in terms of access control, in terms of security, in terms of encryption, in terms of all the privacy mechanisms to ensure the fact that it typically meets the required compliances of the domain under question. The third challenge happens to be the throughput, right? The way the information and the content can be delivered, at what rate can it be delivered, what type of bandwidths are required to deliver this sort of a content, and so on and so forth. So when you talk about throughput, there are a lot of issues which come up out over here, typically starting from the network throughputs to the application throughputs to the scalability and load balancing. All of that typically come together and they have some impact on the throughput for the application delivery at the required point of consumption. Right, so these are the three challenges to the cloud, and let us see how we can address each one of them. When you talk about latency is all about trying to deliver the information, and this is normally measured in what is called the round trip time. The round trip time essentially is a scenario wherein the moment I send out a request for some content, the request is processed and the content is delivered back to me. So what exactly is the total time it takes to get my information? And this is essentially what is called as a round trip time. And when you talk about a uh, uh, delivery of information onto, let's say, mobile devices, and when the consumer is maybe 100 kilometers away from the provider, then your typically the round trip time goes for a toss, right? So the objective is I need to achieve a round trip time of the order of 1 millisecond, and if at all I need to have it within 1 millisecond, the consumer has to be within, let's say, 100 kilometers of the actual the cloud source or whatever it is, right? So that is one basic problem. So if you look at the latency, this is a classic bunch of measurements which have been taken after experimentation. You are currently using, let's say, fiber technology, and this particular fiber technology typically sends packets over fiber link at the peak rate of about 2/3 the speed of the light. And if that is the peak speed, and packets traveling from New York to San Francisco typically will take about 21 milliseconds. And so, which also means that the round trip time happens to be 42 milliseconds. So it might be good if at all you talk in terms of an application where the latency demands are about 70 milliseconds and all. Whereas if the same application has to be accessed, let's say hosted in New York, and I would like to access in London, this round trip time typically shoots up to 68 milliseconds, in which case maybe my latency demands are not properly met. It is not just only this, the last mile delivery of content is also very, very important. That might add up to some additional delays ranging from 10 to 65 milliseconds. So all in all, you can achieve maybe a complete RTT or latency of the orders of about 100 milliseconds with the current fiber technologies. So how do you try to handle this? There is another example which I've taken with regards to latency measurements from a very popular gaming application, and this popular gaming application happens to be the PUBG. And very quickly you can just run your ping command and then identify what exactly is the RTT. And if you notice, the RTT ranges anywhere from 135 milliseconds all the way up to about 400 milliseconds. That typically is the range. So which also means the fact that PUBG might not really give you a very good immersive experience as it is supposed to be doing, until and unless you just have a totally different form of delivery of content. All right. The second issue is about data privacy. So data privacy can be addressed by putting up your security filters, and normally the security filters are implemented at the central cloud infrastructure, right? So that the information that is kept at the central infrastructure is safeguarded, right? This is a small example of a requirement. For example, you have got some medical data, and if this particular medical data has to be uploaded to my central servers, it has to be anonymized, right? I just probably cannot have my personal details set up as part of this particular information. So I have to anonymize, and that activity has to be done through a small filter which I apply and put it across at the central cloud infrastructure just before I store this information. Right? So is it possible now to do this sort of an activity right at the point where the information is getting generated? Let's say I've got a Fitbit, and the moment I have data captured by my Fitbit, if this particular data has to be published onto maybe, let's say, the cloud, can I typically do this activity of putting up my security filters directly into the application which is bundled into my device? Now, this is another scenario which you have got a typical use case leading to data privacy. So when you talk about the cloud implementations, we said that normally the cloud implementations are put up as virtual machines. Virtual machines are reasonably good, but they still have their own drawbacks. They are bulky. they are pretty heavy in terms of the demands for resources. Very simply because every time you have got a virtual machine instance, you require its own copy of OS. You have to have provision for the runtimes for your applications, the libraries, you just name it. Everything actually adds up together, and this is reasonably heavy in terms of the resources that are required. Second is, the cost of migration of these VMs is also pretty very high, right? So these are the two issues which are major deterrents. When you talk about handling maybe 100,000 such VMs, deploying and managing these VMs also becomes a very, very tedious task, right? So VM deployment, VM management, all these costs are very expensive propositions. So the question is, how do I come out of this? So is it possible for me to look at something which is a lightweight in nature? Can I think about a lightweight virtual machine? Can I also think in terms of a mechanism wherein I can manage and orchestrate a large amount of VMs in maybe a few fractions of seconds? Now the question is, if at all I have got these sort of technologies and incidentally they are available, can I not typically think about using this similar type of technologies and then put it onto a cloud infrastructure, which is pretty very close to where my applications are supposed to be running, right? So that is once again the context out over here. So what are the basic possible solutions? I can talk in terms of using low latency, high throughput networks, right? That will definitely reduce the so-called latency. And one possible promising technology happens to be the 5G technology. So I can now talk in terms of integrating 5G technologies into the cloud infrastructure, right? We call this as a 5G edge cloud infrastructure. So that is one possibility. Second possibility is it now possible to have a lot of local processing to be done at the point where the data is captured, at the point where the data is required for consumption, rather than pushing it down to the central cloud, right? So that is the second option. The third option is try to bring in these workloads which are very lightweight workloads. So instead of having these VMs which are reasonably bulky, can I think in terms of an alternative VMs which are light in their content, light in their management? So that is the third option. And the fourth is, I told you, the entire cloud infrastructure, is it possible for me to bring it down exactly to where it is, where the infrastructure is needed? So here we come down to a case like, don't bring the entire cloud. Have a small fragment or a partition or a slice of the cloud. Let us call this as a micro cloud or a mini cloud or a nano cloud, or maybe a cloudlet. You can just give it any name. Bring this down to a point which is absolutely closest to the place where you're going to consume information, where you actually require the infrastructure. And this is the paradigm, and this particular paradigm is where you're trying to bring the cloud closer to the user, and we also call this as a cloud at the edge. So once again, to make this happen, I told you low latency networks is possible through 5G. Lightweight deployment units can be made possible through containers. And you talk about bringing in slices of this cloud infrastructure in a slightly smaller version, and then you call this as edge cloud infrastructure. So we will be spending the next few more minutes in discussing about each of these areas. So what is the first catalyst? I told you 5G happens to be the first catalyst. 5G offers absolute blitzering speed communication channels, which is promising absolutely low latency. And this makes low latency applications to conveniently run. And we talk about latencies of the order of a few milliseconds. When I say few milliseconds, in and around 5 milliseconds. And we also talk in terms of bandwidths that typically support up to 10 gigabits per second type of a data rates. And when you talk about the number of connections it can typically handle, it's almost about 100 times more than what your 4G typically can make it possible. This is the technology that is available. So this has got a lot of promise, and we'll try to integrate that with the demands that are required for edge computing infrastructure. So the second catalyst is, I told you, we need to somehow reduce the strength of the virtual machines, make them lightweight, and containers give you that sort of an opportunity. And what is a container? It's a complete lightweight, independently managed infrastructure, and this particular infrastructure will have its own associated application with the data resources, and this can be deployed anytime, anywhere, and managing them is absolute ease. Right, they're very, very lightweight, because of which you can bring up a container with probably in less than a few seconds. You can just migrate them, you can just play around them as small individual entities, and the applications are built in containers as microservices, and because they are microservices, you don't bundle the entire application, but small features of applications are what are implemented in microservices, and that is the reason why these containers become very, very lightweight. And as I told you, they can be spawned and started and stopped with ease, and then you can have a single point of a control across all these containers. So Docker is a classic example of how containers can be orchestrated, how containers can be set up, and to manage these Dockers in terms of deploying and managing, etc., we have what is called as Kubernetes. Right? So Kubernetes is once again a very, very popular technology. It has now become proven across the industry, wherein you can just typically achieve a high scalable delivery of application services through microservice implementations in containers. So basically the containers are Docker containers, and Kubernetes allows you to set up all these containers, containerized applications, and orchestrate them and manage them through the Kubernetes. Right, so essentially it allows you for automated deployment and scaling and management of very large scale containerized applications. So the question is, can I now have this Kubernetes also onto the infrastructure, which I typically bring it down to the edge? The answer is a big yes. And the third catalyst I told you is about edge computing. We'll talk about what this edge computing is. It is essentially a computational model. Just imagine you have got a cloud, which is a computational model. The same cloud computational model is now brought up to a consumption point where the latency is absolutely very, very low. Right? So when you talk about the cloud computing model, the entire computations is essentially carried out at the back end, right? At the so-called centralized server. Whereas here you talk about setting up a computational infrastructure where the computation is actually carried out very, very close to where the data is actually available, where the data is required. Right. So at the point of the first point of contact of the data could be a point where I can just pick up the data and probably do some computation, and this is implemented in a edge computing scenario. So let us quickly look at what is this computing at the edge. Technically, it is like pushing the applications and the data and the entire computing power to the edge of the network rather than putting at the core of the network. We try to push this entire thing to the edge of the network in absolute close proximity to where they are required. It could be done in a mobile device, or it could be done very close to the sensors and actuators in an IIoT implementation, or it could be done at a point where the users actually demand this data for consumption. And all this is typically achieved through edge computing. And hitherto, when you talk about high scalable content delivery for web-based applications, we have a very popular scenario of putting up CDNs, content delivery networks, and CDNs more or less act as a caching mechanism or content storage mechanism at the closest point where you can deliver it down to the bunch of users. So it is something like a network where the content is actually cached at the closest point of consumption across a bunch of users. Okay, that's a CDN. So CDN is maybe I should say a forerunner to edge computing. So what goes into this edge computing? Primarily, you bring a cloud resource or a cloud infrastructure very close to where it is required, with the primary objective of delivering these services with a latency which is of the orders of a few milliseconds. Something like 4 to 5 milliseconds is what exactly is the target. That is what edge computing is all about. And I told you 5G is once again a very important player. And now just imagine your 5G provider. Currently, you have got this 5G, 4G providers. They provide you with some other appliances. Now, for example, Airtel provides you with an appliance, and that particular appliance is something which you can hook it up into your home. And the Airtel guy provides you with a data connectivity so that you can run a whole bunch of appliances in your home over the internet. So here you have got a CSP who is giving you a 5G box, and that particular box is giving you a gateway to the internet, right? Similarly, we can talk in terms of a CSP, and this guy can now provide us not just only with the 5G interconnect for data, but tomorrow probably he'll also be giving us a small box, and that particular box will service the computational requirements of whatever is the application which I would like to run. Right. So this is the scenario to which we are essentially trying to move out to. And industry statistics show that as of today, 10% of the enterprise data is currently getting processed at the edge, and pretty very soon by the year 2024 or 2025, they estimate that almost about 75% of the entire enterprise data will be processed at the edge. So that once again shows a lot of promise, where you require some sort of a computational infrastructure to be scattered all over the place. So let me quickly get on to a few of these topics, right? And let me show you a bunch of these use cases. So if you look at the edge architecture, we have got a very simple generic architecture. We normally have got infrastructure right at the bottom. My goodness. Yeah. We have got the infrastructure right at the bottom, and that is typically what is called the far side, far end of the entire information delivery. When you talk about the information content, we start from the core. The core is out over here, the centralized infrastructure. So any endpoints which are out over here for information consumption is called the near edge, and information consumption at the device side or the device end is called the far edge. Now, once again, you have got intermediate layers where I can now talk about putting up part of the content, part of the applications to run out over here, not necessarily on the core infrastructure, but an intermediate infrastructure which is reasonably close to the point where it is required for consumption. Okay, so with this, let us see a few of the use cases which I spoke about earlier on. So this is a very simple scenario wherein we talk about putting up a private edge. Remember the same picture which I had shown you earlier on. Here we have the local corporate network, and this particular local network is now loosely called as public infrastructure edge, which allows you to access the so-called public infrastructure on maybe AWS or Azure. And you have got the internet edge, where the corporate infrastructure talks to maybe other internet applications, maybe extranet or intranet or internet applications. So the second type of a endpoint. Then you have got all the infrastructure which is there within the organization. So this is also loosely called as a WAN edge, edge devices over a WAN. And when you talk about putting up your infrastructure which is going to be private, then you say this is my edge, which is absolutely a private edge. So the moment you put up this private edge, this particular edge infrastructure now is integrated into the organization or enterprises network, number one. And this now offers you all the required security models. It is not exposed to the public. So it is a purview to all the security models, whichever is really required. So you have a very simple, secure or high secure edge environment set up for your requirement. When you talk about the gaming like scenario, which I spoke earlier on, once again, you have got a 3-layer architecture. You have got right at the bottom, the devices which actually try to consume the data, and then they connect over to the so-called access points, which are 5G enabled access points, and they typically reach out to information for both for content as well as processing on a infrastructure which is called as an edge node infrastructure. So the services are no longer delivered from the centralized resources, centralized infrastructure, but they are made available from this edge node infrastructure. So this way, your entire latencies are reduced drastically from maybe 50 milliseconds down to maybe about 8 to 10 milliseconds, which is a marked improvement in the requirements and the demands for mobile and gaming consoles. Coming down to IIoT, you essentially have got at the sensors level, got all your sensors and the typical controllers, and then you set up normally your gateways. Now this time, instead of just having normal gateways which are aggregators, here you talk about edge gateways where the processing is also done out over here. Maybe it could be an analytics processing, maybe it could be a SCADA type of a processing, whatever it is. The processing is also done at the edge gateways, and ultimately you have this entire information also published onto the cloud for sharing across to other stakeholders as well. Right. So this is an IIoT and edge. Once again, you have got the 3-layer model. So what is typically required? You require to set up what are called as data centers at the edge. So these are called as edge data centers. So what goes into an edge data center? First and foremost thing is you will have a bunch of connected devices. This could be, the so-called endpoints, and these endpoints could be fixed endpoints, or these could be mobile endpoints. And all these will have to be connected primarily to the so-called data center, the backend data center. And this is a traditional approach of directly connecting over to the normal traditional centralized data center, the infrastructure. But what is currently defined as an edge data center model is you're going to use some form of a interconnect, which is a low latency interconnect. Maybe it could be a 4G or a 5G or LTE type of an interconnect, cell interconnect, and you will have a small data center absolutely close to this. So this particular data center is the data center which sort of mimics the entire infrastructure which is available at the traditional data center, but in smaller in size. So you normally call this as a micro data center or a nano data center, depending upon how much you would like to provide here. So you have got a data center which is very, very close to the cell tower, because of which more or less it appears that you have essentially only one hop of a transit of information from the point of consumption. Okay, or it could be put up also at a customer's facility, and this could be once again an intermediary of a data center. But once again, this is not on a full scale, but it is on a small drill down type of scale, right? And please once again understand, when the game changer for this happens to be setting up this interconnect to this particular micro data center over a network which is absolutely low in terms of its latency. So this is once again another use case. This particular use case is for connected vehicles. So you have got vehicles, and all these vehicles have to be provisioned with an infrastructure so that you have got a vehicle-to-vehicle interfaces which are provisioned, and that is once again set up on a 5G network. And all these vehicles have to be under the control of a 5G base station, maybe here. And 5G base stations typically have their own limited area of access and area of control, maybe of the order of about 800 meters to maybe even 1,000 meters, let us say. This will deliver a whole bunch of application scenarios for management of this entire vehicular traffic. Second requirement is there would be an infrastructure on the roadside, and these are primarily for traffic management like traffic lights, etc. And that traffic lights will have to once again talk to the vehicle. So we call this as a vehicle to infrastructure, V2I, or vehicle to roadside infrastructure. And this is a separate channel of a communication. And some form of a processing has to be done out over here for estimating what exactly is the traffic loads and what is the density of the traffic, what is the rate at which traffic is flowing, and all that sort of analytics has to be done out over here itself. And to do that, we can now establish a cloud infrastructure. This is called the multi-access edge cloud, MAC as we call it. Now, this multi-access edge cloud can have a wide variety of applications that are running, a bit of analytics, bit of control, bit of information, and they could also be connected over to a backend so as to provision to the user some form of media. Maybe map information, map services, navigation services, all such applications can also be extracted through the backend, and this MEC cloud acts as an intermediary for this, right? So you have now a complete scenario wherein you have the cloud, which itself is now partitioned and distributed, right? And this is very much possible where you now bring in the cloud infrastructure, not from the centralized pool now, but to a point which is absolutely close, maybe about 1 kilometer away from where it is actually required for the user. So in the context of this vehicle and traffic management, we have this activity of task offloading, and just notice the fact that if the vehicle is moving from one place to another place, very much like you have got the voice calls being rolled over, here also you have to offload the task. So here you talk in terms of migrating the complete workload from one edge node down to the another edge node, right? So this is one thing which needs to be once again handled by the infrastructure that is put up into the MEC servers. So this is how your edge data center typically could look like. Normally it is a one sort of a container. When I say container, not the Kubernetes container, but this is essentially a physical container. And this is one rack that gets implemented internally. It could be one rack or two racks, or maybe a multiple set of racks. And each of the rack could be a 42U rack or 24U rack, depending upon the configuration that you require. There would be multiple servers. It would have internally all that is required for power conditioning, network for communication. There's a backhaul which you can directly connect it over to the antenna masts which are there. And then even the HVAC is also implemented. And all of that typically give you an opportunity for management with an unmanned manner, right? So this is how, if you just look at it internally, this is how your edge data center looks like. You'll have the two racks over here. Then you'll also have got your top of the rack switches and connected over to your network infrastructure with a backhaul directly connected over to your 5G network. Then you will have the fire safety equipment, you will have the ventilation, you will have the air conditioning, you have a power supply and two stages and 3 stages of power supply. And all of that typically would be provided in a container. And this will be more or less be unmanned, right? But it can be managed from a remote place. So you have to have a different category of edge data center management tools. So this is a small example where I picked up. This is a traffic management as an example. We have to manage the traffic flow, estimate traffic delays, and maybe you have a camera which will be capturing the number plates of vehicles if they are crossing the lights, and you have to capture this and then typically send out a ticket. So this is an image capture, and that particular image capture requires a slightly different type of workload. You have to once again send notifications and alerts in real time. You have to once again have applications which integrate with map servers and navigation applications. All of these are different forms of applications. If you just look at this traffic management itself, you have got applications which are typically having less demand down to some high demanding requirements of both compute as well as latency requirements. So you can now typically think about putting up a data center in a small box. So we call this as a data center in a box, and you can just put it at the roadside, very much close to the traffic lights. So this could be a very simple single box, single unit implementation. Once again, satisfies the requirements of acting as a small data center. So I'm just taking an example of what is provided by Dell. Once again, I'm not from Dell, but this is some information which I readily found, and maybe I thought this is reasonably current. And Dell has their own MDC, which they call it the Modular Data Center, and that's a Dell EMC, and it's essentially a 48U rack, and you can go into 1 to 20 rack modules. And typically when you look at the server, it is a 16 Xeon CPU which you can have, and you can also add it. It comes up with a default of 2 NVIDIA GPUs, but you can just enhance it up to 16 NVIDIA GPU servers. And the RAM that it gets supported is anyway from 64 to 128 gigs. And then you can have once again storage in the form of base going anyway from 8 terabytes all the way up to 92 terabytes of storage. And it is also attached to an enterprise class 10 GB switch. And a bunch of additional infrastructure is also provided in the form of a small embedded PC, primarily used for monitoring purposes. So if at all you have got local monitoring to be done, that local monitoring can be done through this embedded PC exclusively for monitoring. And this entire data center also has got a 3 to 5 kVA smart UPS. Once again, for redundancy, you can have N+1 or 2N type of models for power. Then there is a ventilation which is provided, a free and forced ventilation, temperature humidity sensors, and waterproof cable outlets, so that this cable gets connected to the network infrastructure. Right? So this is what is integrated into one modular data center. So what are these workloads? Remember, I told you about different types of workloads. And these workloads are a variety of these workloads. Some of them are high demanding in terms of the compute resources. Some of them are demanding in terms of the latency. You know, you have got a variety of workloads, and you have to appropriately identify your use cases and appropriately put up what exactly is the required infrastructure in the edge data centers. And the workloads could be streaming media workloads, AI/ML workloads on time series data, more specifically in the context of IIoT applications. You would typically be having image processing type of applications, like I told you about the camera, which is capturing your number plates, and then it is performing some image processing on this. Then you also could be having radar signal processing. If at all you are having a LiDAR sensors and stuff like that, you know, you have to do signal processing on radar data. Or in some cases, it could be also media-rich gaming type of an applications. And moving from gaming, you now have got the demands for immersive metaverse-oriented applications, which are AR, VR, and XR, extended reality type of applications. And all of these are challenging applications to implement, and edge probably gives you a good opportunity. Or edge computing gives you a good opportunity to implement them. Obviously, the challenge still happens to be the security. More specifically, when you have got so many points at which data is going to be stored and captured and processed and published and moved out and in, you have to put up robust security models out there. So security still happens to be a big challenge, and people are working hard to address this. More specifically, because there is a lot of transit points for data moving in and out from the edge compute models. Second challenge is about deployment and management. And deployment and management is normally very easily taken into account by using the Kubernetes, the standard Kubernetes model, where you talk about identifying a bunch of pods going or pods housing the so-called containerized applications, and bunch of these pods set up into a node, and a bunch of these nodes making up a cluster, and this entire cluster could be housed into a single edge data center. Right? So Kubernetes gives you a very good opportunity to have a scalable type of an architecture to deploy rapidly and manage easily a variety of applications with different workloads at the edge. And when it comes down to the security, you also have got 3GPP 33.210 and 33.310, one acting at the network layer, other one acting at the application and authentication purposes. Both these two specifications are robust, well-defined specifications, and they can be very clearly implemented through the so-called security gateway policies. So you also have these security models which are available, which are reasonably well proven, but you know, is until and unless you typically deploy it and then see these things operation at scale, we really cannot completely trust. So people now talk about zero trust networks, right? A network where I'm typically not going to have any trust on the network. So people are thinking in terms of building zero trust networks also on the edge cloud infrastructure. So what are the tools that are available for deployment? Okay, you talk about applications. All these applications are going to be containerized. That's number one. And you have orchestration, and you have got a whole bunch of orchestration tools that are available. And these could be rule-based orchestration services or even script-driven orchestration services. You have got tools even available. And these regular tools can very easily be used also in the context of a cloud infrastructure. I've just put up a bunch of tools which are available, like Akame, Cloudflare, CDN, Chef, Ansible, AWS Code Deploy, Google's Anthos. All these are classic examples of tools which are available. They can be very easily integrated into your edge data center. So that is my talk. And in quick summary, I spoke about what edge computing is and what exactly is the real requirement for this model of computation. And we said that edge, along with the cloud infrastructure and 5G, all of them bundled together, give you an opportunity to deploy large voluminous applications which are high demanding in terms of compute requirements, in terms of latency, and in terms of seamless access over a wider network. And we also have identified what is meant by a micro data site and what exactly is the infrastructure which goes into a micro data site. And people talk about implementing what are called as cloudlets, fragments of cloudlets. People also have coined a different word called as fog computing. The Microsoft people have got a different terminology for that. They talk about this entire thing as a fog computing models. So all of them typically mean the same. I did not really focus upon any specific vendor. I just gave a generic treatment to my to this entire concept. That completes my narration. So Prakash, in case you have any quick questions, I can just answer them.
Sure. Excellent fundamental presentation, I would say. Basics, and I like the flow and going from use case to the requirements and projecting what exists in the industry. It's a very simple, straightforward, understandable concept, and ending with security and all. Now, of course, these are edge has been there evolving almost for 10 years. A decade has passed.
Right.
And so it was it could have been done with what you call 4G as well. It could have been done with broadband. Um, Everything takes time. And so how do you see the 5G and broadband, where fixed and mobile convergence has occurred? Today, you don't even talk about, nobody talks about fixed and mobile. They talk about just the application. This is application-centric view which you have brought, where you are not really getting into anything like telco or anything. So it's wonderful. Do you think that application-centric architecture will be the key for next decade?
See, when you talk about deploying applications, why am I bothered really about whether I'm really looking at fixed or whether I'm looking at mobile or whether I'm looking at broadband and all that? As long as I can just get my content ready, just provide me the infrastructure, I'm ready to deploy my applications. That is basically the central theme. More specifically, if at all you talk in terms of putting up edge deployment, which is a private edge deployment. Right. Let us say I have a requirement. I'm just giving you a use case, which I'm just, in the design phase. The use case is something like this. There is a company which is interested in putting up these EV charging stations. And he's talking about putting up an infrastructure, not just only for just charging, but he specifically wants to have a mechanism by which he is going to monitor the status of the battery. He's going to monitor the car coming in, car going out. He's going to also monitor the time for which it is charging. He's also going to handle the payments. all these sort of requirements have to be done from a centralized place, and then he's typically planning to set up something like 8,000 such stations across a given region. Now, he's really not bothered whether you are going to really use a fixed or a mobile type of a interconnectivity. The traffic demands have been analyzed, and as long as you have got maybe in a fiber, essentially in India, you have got good access. Fiber is also giving you a very good throughputs. Maybe about 100 megs of a bandwidth is also good for this sort of a use case. If at all it meets that sort of a demand, then why do you have to really get on to setting up a private 5G infrastructure? And private 5G infrastructure might be a good choice if at all the area of coverage is small. In the current use case, probably they have decided to go by the so-called infrastructure, which is your fiber fixed network infrastructure. So it depends upon the use case to use case that needs to be worked upon at that particular point of time. Ultimately, whether it is a 5G or a 4G, LTE or fiber, it all depends upon the context of what exactly is the latency demands of your application. That is going to be the design criteria.
Exactly. I think you hit the nail on the coffin. Here, I see something which always what you call amazes me. So you got to have latency, low latency. You need to have reliability. You need to have throughput, so you can speed it up. So that means you need to have computation acceleration closer to the what you call the consumption as well as the production. So now ultimately it boils down to then that is it likely that COTS will continue, or we'll have to accept that besides the COTS, we'll have to allow some proprietary hardware and the software to make things practical in real life applications?
See, I am a strong proponent of open source, and I'm a proponent of COTS. Anything that is available off the shelf is something which you need to pick it up and then put it across, integrate it so that it becomes affordable, maintainable, easily deployable, rather than getting onto maybe core proprietary type of implementations. If there are some very, very specific use cases which actually demand those sort of infrastructure, maybe the answer is yes. But for the regular industrial requirements, industry use cases, I think COTS is pretty good enough.
Okay, I think fantastic thoughts and what you have brought in. I think our research folks will appreciate the fundamental that is required and to go on to the research which makes sense for the practical usage rather than just having the number of papers or number of uh, what do you call the engagements in the conferences. So with that, I think I will end today's session, and thank you very much for providing your time and effort and to ensure that we get the quality that we were looking for. And with that, I will end the session.
Thank you very much.
Any last word for you?
No, thank you so much. Thank you for the opportunity, and it was nice to share my thoughts on this topic.